All right, example 1, describing the graph of a sinusoidal function in degree measure. So we have a graph here, and you'll notice that the domain, all the x values are in degrees. So it's important to note what the unit is on your x-axis, because it could be in degrees or radians, or it could be in other units such as time. Now the minimum value always corresponds to our y value. So you would choose any minimum y value. You could choose this point or this point or this point, and they should all have the same minimum y value. So choose one coordinate. 0 is always a nice easy one to choose. So we have 0, and the minimum y value is here, -3. So for our minimum value, we would say y is equal to -3 is our minimum value. And the same would apply to our maximum value. We would choose any of these maximum points. Doesn't matter which one you choose. Okay, but let's just choose the first one. And we would look at the measure of that. And we would notice that the x looks like it's around 90 degrees, which isn't really important for our maximum. And our y value looks like it's 7. So our maximum y value is going to be 7. Now our range here is just the possible y values that are within these two values. So you always use your minimum and your maximum values when determining your range. So we're going to say that for our range, our y has to be greater than -3, and it has to be less than 7. So your range should always be so that y has to be greater than your minimum value and less than your maximum value. And y can be any real number in between -3 and +7. Now the midline, there's two ways that you can determine the midline. You can use the formula that we talked about in the last lesson. So you could do y max plus y min divided by 2. Okay, so my maximum y value is 7 plus my minimum y value, -3, divided by 2 should give me my midline. 7 plus -3 is 4 divided by 2. So my midline is 2. Okay, so my midline is at y is equal to 2. And let's just verify this by drawing it onto our graph. When we're drawing it onto our graph, it should look like it's cutting the function in half. If it doesn't look like it's cutting the function in half, probably something went wrong. Okay, so we're going to draw in our midline here. We can see that it's cutting the graph in half. And you can also count to verify. So if I count from the minimum value up, 1, 2, 3, 4, 5, and I count from the midline up to the maximum, 1, 2, 3, 4, 5, it should be an equal distance to the maximum and the minimum. And that equal distance that we just counted is our amplitude. So our amplitude is half of the distance of the whole graph. So it's the distance from either the midline up to the maximum or the midline down to the minimum, which we just counted out to be 5 units. Okay, if you want to use a specific formula for amplitude, you can use the formula y max minus the y from the midline, and that will give you your amplitude. So our maximum value was 7 minus our midline, which was y is equal to 2, and that would give us our amplitude, which is 5. Now, to find the period, it's a little bit trickier. We just need to go from one point to a repeating point in the next cycle. So the easiest one to choose is the maximum to maximum generally. Okay, so if we choose our first maximum to our second maximum, and we have to identify these coordinates. So this one is 90 and 7, and our second maximum point is at to 70 and 7. Okay, and then to find our period, what we're going to do is we're going to subtract our x2 maximum, so our second x maximum, and then take that and subtract our first x maximum. So in this case, we would do 270 minus 90, and the period is 180 degrees. So if we're looking, this graph should repeat every 180 degrees. So there should be 180 degrees between these two maximums. There should be 180 degrees again between the next two maximums, and so on and so forth. Okay, if you look at a different point, there should also be 180 degrees between each of the minimums. So they should repeat every 180 degrees. No matter which point you choose on the graph, it should cycle every 180 degrees if that's the period. Okay, and the domain, you'll notice that this graph is continuing on to the right. There's an arrow showing that it's going to continue outwards into higher and higher degrees. And it's also going to continue to the left, and we could go into the negative degrees as well. So for our domain, it's really easy. X is just an element of the reals. We could have any x value as part of our domain.